In this video, we'll learn about the Shell Theorem and its implications as we're studying the gravitation of real objects. The Shell Theorem says that a uniform spherical shell of matter attracts a particle that is outside the shell as if all of the shell's mass were concentrated at its center. Furthermore, a uniform shell of matter exerts no net gravitational force on a particle that's located inside of it. Here's what that means. If we were to have a shell of matter, you could think of this like maybe a hollow ball, such as a basketball. If I were to look at the gravitational force exerted on a particle out here, then it would act as if all of this mass were located at the center of mass, and the R value that I would use would be the distance between this center of mass and my particle. If instead my particle was located inside of my spherical shell, there would be no net gravitational force on it. That makes a little bit of sense if you think about it, because a particle, a little piece of that shell that's right here, would be exerting a fairly large force since it's close. It's a fairly large distance. We'll say that it would be exerting a force. Remember, it points toward it, so it would be exerting a force this way. But then that force would be canceled out by the lots of pieces of matter that would have kind of those Y components located over here. So that's why there's no net gravitational force inside the shell. Now, here's why that matters. We're going to think about what would happen as we were to go to the center of the Earth. So if we think about Newton's Shell Theorem, then when an object is at a radius r from Earth's center, the portion of Earth that lies outside the sphere of radius r does not produce a net gravitational force on the object. What I'm saying here is that if our object were inside Earth, a distance r from the center, so there's my distance r, I don't care about all the mass that is outside of r. So all of this mass out here does not affect the gravitational force. Only the stuff inside r does. Furthermore, the portion of Earth that lies inside the sphere does produce a net gravitational force on the object. It's almost as if that mass that's outside of r doesn't matter. And lastly, we can treat the mass of that inside portion of Earth as being the mass of the particle located at Earth's center. We'll do some examples with these concepts in class.